really quickly. And then we'll have a look at a summary and some study tips that I have for you guys. But if you do want to go through those motion examples, please feel free to. The slides are available for download. I believe there's a few answers in there as well that you can go through, check your working, check your answers. All right? Okay, let's do just a quick intro to sine and cosine rules. So, sine, cos, and tan are the ratios that we use for right-angled triangles. All right, when we have a 90 degrees angle in the triangle, and you'll be familiar with those. However, a lot of the time in year 12, you actually don't have a triangle that's right-angle triangle. All right, and for the purposes of this lecture, we're going to call right-angle triangles, we're going to call them rats. This is what my methods teacher called them when I was in year 12, and we thought it was hilarious. Because, you know, you can just be kind of talking very seriously about maths, and then out of nowhere be talking about rats. Anyway, so when you have no rats, or you have a non-rat, you need to use different types of rules to figure out the angles and the sides. All right, so these rules are the sine rule and the cosine rule. We can also calculate the area of a triangle for a non-rat. All right, so when you're looking at the area of a rat, we have half base height, right? But when you're figuring out the area of a triangle for a non-rat, we actually have a different formula for that. So let's get into the sine rule. This is the sine rule here. It's written in your formula sheet, and it looks a little bit complicated to begin with, but I'm going to go through and explain what everything means. And hopefully you have also had a little bit of a look at this in year 10 potentially as well, so it might ring a few bells. So what are all of these letters? What do they all mean? Right? So we have lowercase and uppercase. What do those mean? Well, the lowercase are the sides, and the uppercase are actually the angles. So instead of using like theta, alpha, beta, all those Greek letters, we actually just used uppercase letters. And as you might be able to tell, the uppercase letter is always opposite the lowercase equivalent. So A opposite A, C opposite C, B opposite B. All right. So what we're really saying with this sine rule is you have the side over the sine of that angle, side over the side of that angle, side over the sine of that angle. So let's go over an actual application of this. Say we were given this triangle here, and we need to find the length x. So we know that one of the lengths is 7, one angle is 120 degrees, one angle is 45 degrees. This is not a right angle triangle, so we can't use our sine, cos, and tan ratios. We need to use our sine rule. Now, when we get into the cosine rule, I'll actually explain how you know when to use the sine or the cosine rule, because it's a little bit different, but for the moment we'll just focus on actually using the sine rule. You can just kind of take a chunk out of it. You don't need to use all three of them. You just take a chunk out, because we only have one value here. So we're going to have, the side x over the sine of its opposite angle, which is 120 here. Right, because this is A, this will be B, and this will be B, because those two are opposite too. Then we're going to have 7 over sine 45. And now, as you can see, the only unknown we have is x, which means we can just isolate it. So we're going to have 7 sine 120 over sine 45. Now, hopefully you guys will be familiar with the unit circle and how you can actually do those exact values without a calculator. But because we just kind of want to focus on the sine and cosine rules here, I'm not going to go over that. I'll just give you guys the answer. It's about 8.57. That's not an exact value. But if you're able to do that in exact values, congrats. Alrighty. Let's have a look at a few more examples here. So here we could find these two lengths, x. So we could have x over sine 65 is equal to 2 over sine 75, and solve for x there. And we could have x over sine 110 equals, and now as you can see, all right, we actually don't have this side here. So we have this angle, 38 degrees, but we don't have that side. So what are we going to put here? Let's think about it. We have this length here, which is opposite this angle. So we can actually find out what this angle is because we know the other two. So we know that all of the angles in a triangle is 180, so we're going to have 38 plus 110 plus, and then let's call this B, plus angle B. So we can figure out what angle B is using that method, which is 32 degrees. So we're going to have 5 over sine 32.